Check nice, check twice. Continuation. Get to Euclidean. Euclidean. Everything you need, everything you have to know about Euclidean geometry is everything you need for mathematics. Yeah. So this topic is essential, right? Um, you are given ABC, right? You're given that is a straight line. You have angle ABE being equal to 65. There's a 65 there. You have DBE 45. And then you have BDC, which is 48. Now, calculate the value of B. They're giving you a statement. They say 65 plus 45 plus B. They're equal to something. What do you think? I know you said this. I know. 180 degrees. Adjacent, right? These are adjacent angles on a straight line. Right? Angles, if angles lie on a straight line and they're next to each other, there are sum equals 108, right? You see adjacent angles on a straight line, right? Supplementary. Big words. It's not really big. B is going to say, we're going to say 180 minus 65 and 45. So this is going to give you 70 degrees. That is the value of B. Now, if I continue to the next question, right? So you're given A, B plus 40, right? So the sum of, let's look at A. You have A, B, and 40. I know you said that. I know you said that thing. I know you said 180 degrees. Why? Some angles and a triangle, right? That if I add all the angles inside the triangle, they give me 180, right? I know that B is 70, right? I know that B it's 70. So what I'm gonna get, so A is also 70 degrees. Now I have 70 here and 70 there, right? So this is a very special thing. It's something that is not really special, but there's observation. I knew it. So it's saying, what can you conclude about triangle BCD? Must give a reason. Your conclusion. Since the angles in a triangle, since the interior angles are equal, right? So it would mean, it would mean, that would mean this is 70. It means this side here is going to be the same as the side because the angles are equal, right? So this is a nice thing about geometry. Right? I want to show you something. So if this is what I have, A, B, C, right? If A, no, if B equals C, this thing becomes if this is equal to this, then these sides are going to be equal. I'm gonna say opposite and angles opposite equal sides are equal. The angles that are opposite equal sides are equal. That is why. That is the reason BA is equal to CA. That is why. So when I get to this question here, when I get here, oops, I'm gonna say my reason. I'm gonna say BCD. Triangle BCD is an ice. isosceles triangle. Reasons, angles, opposite, equal, sides are equal. Remember, this is a different thing from answering the question. If the question, when you're given a reason for conclusion of a triangle, right? Normally, you do this. Normally, right? This is what happens. If I have A, B, C, right? You say B equals C. Your reason is angles, opposite, equal, sides. That's what you use. But now, when you are saying that AB is equal to AC, your reason is angles, opposite, equal, sides. Equals. Thank you. Those are the conditions of the isosceles, remember? And now, let us continue. Let us continue to the next one. You're given a quadrilateral A, B, C, D. AB is equal to BC, and then AB is parallel to DC. Now, what's the term? There's a term for this thing. There's a term, presumptuous. Don't be presumptuous and think this thing is a parallelogram. It's not, or a rhombus. They didn't say that thing. They didn't say it. They said to you it's a quadrilateral. So you have AB equal to DC and AB parallel to DC. Now, in triangle ABC, ABC and CDA. I know something. AB is the same as BC. I know it because they told me. That's why I'm going to say this. I only say this when I see it. Don't come like, never mind. Now, AC. Look at AC. AC is common for both triangles, right? CDA. CDA and ABC. AC is common, right? AC is common. I don't need to give that reason. Oh, I can do this. I can say same thing. AC equals AC. Then my reason is that it's common. There we go. And then now, there's parallel, guys. When they speak about parallel lines, please, when they speak about parallel lines, when they speak about parallel lines, when they speak about this thing here, you must think of number one, alternate angles. You must think about corresponding angles. You must think about co-interior angles. Those are the things that need to come to your mind. Those are the things that need to come into your mind. When they speak about parallel lines, you must look for the Z shape. Must look for the Z shape, the N shape. Must look for this one. F for fun. Must look for these sort of things. Must look for it. Right, this position here. So you have this thing again, this one and this one. These ones, remember, they are supplemental. Please, they are not equal. If you have something like this, A, this is parallel. This is A, this is B. You cannot say angle A is equal to angle B, co-interior angles. And then you say CK. Then you say AC is parallel to BK. No, you can't. Don't do that. Instead, say A plus B equal to 180 degrees. Co-interior angles. You see, you know your stuff, you know your business. And then now, continuing to this step, look at this angle and this one, this is a shape. Angle A1 is equal to angle C2. What's the reason? Alternate angles. What do they call alternate angles? Alternate angles. We know that AB is parallel to CD. It's very important for you. Then I can conclude that triangle ABC is congruent to triangle CDA. Right, remember the order is important. AB, DC, they're the same. What's the reason? Side, angle, side. Getting to the next question. Given that C and C is equal to D, okay, both equal to 40. E1 is 80. If E1 is 80 and it's next to another angle on a straight line, they must be supplemental. Means that this angle is going to be 100. Because when I add them, they must give me one. You know, 108. Now, I in triangle DEF. What's equal? Angle CFD. CFOB. Okay. Angle C is equal to angle D. This is given. Angle F. F2. F1. It's the same as F2. There's the X there. This one and this one. Vertically opposite angles. Now, if I'm dealing with two triangles, if I'm dealing with two triangles, bro, I wanna show you something. K, T, R, X, T, U. Now, if I say to you angle R is the same as angle Q, and angle W, angle T is the same as angle W. If I say, bro, obviously, automatically, angle K is going to be equal to angle Z. Like, that's like certain to happen. But if I look at this here, this is 100, this is 40. So it means that F2 is going to be fixed. And if this is 40, because of their equal, this is going to be what? 100. Do you see? Sum of angles in a triangle. Sum of angles in a triangle. So angle B2 is equal to 100 degrees. Sum angles in a triangle. Yeah. So we have B2 being equal to something again, E2. Right? Proven. This is proven. E2 we know it's 100. B2 is also 100. So therefore, triangle CFB is similar to triangle DFE. Angle. There we go. Now, let's look at final piece. The final piece. In the figure, you were given that XW is 13. Then you have XY being 8. Then you have TZ being 5. So 90 degrees there, 90 degrees, 90 degrees, 90 degrees. Okay, I'm seeing a lot of right angles. Gotta be right. Calculate the length of YZ. 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 Here's YZ. Here is YZ. Here is YZ. Here is YZ. Now, when I start, I need to know the side. If I get the side, I'll be able to use Pythagoras theorem because there's a right angle triangle there. Right? There's a right angle triangle. This side is also 8. This side is also 8. So these two lines, here it's going to be 13. Here, I'm going to have 13. Right? There's I'll say this first. This is what I'm gonna say first. YT is 13. YT is equal to 13, right? As you can see, this thing here, if opposite sides are equal, right, and I have 290 degrees there, that means this side here, this side here is going to be 9. This side is also going to be 9. So these are properties of a rectangle. That is why ys is equal to 13. Now, I know that the hypotenuse side, yt squared, is equal to the square of the other sides, y squared plus zt squared versus the Pythagoras theorem. So 13 squared equal to 5 squared plus yz squared. So yz squared equal to 13 squared minus 5 squared. Then I square both sides. Square both sides. So I have yz equal to square root of 13 squared minus 5 squared. So when I get to my calculator, so I have 13 squared minus 5 squared. Gives me what? 12. Here's my question. Here is my answer.